Hello everyone, my name is Sana Manchanda and today I'm presenting my project for the operating system, and my project title is Scalable Thread Library Management. This project is designed to visually demonstrate how thread works inside the system. Normally, thread scheduling is handled internally in the backend and is not easy to understand just looking at the code. That is why the project focuses on the visualization instead of only backend logic. This system provides an interactive interface where we can clearly observe how threads are created, scheduled, executed, monitored, and optimized. Let's see step by step. And this system is divided into 6 major sections, that is dashboard, thread management, scheduler, analytics, AI suggestions, and settings. Let's move to the dashboard. Now starting with this dashboard. Now this dashboard acts as the central monitoring system of the entire project. Here we can see multiple important metrics such as total number of threads, active threads, number of completed threads, and overall execution progress here also. That will show me completion rate and waiting and runtime utilization, and average waiting time. Recent activity logs will also show me here. This page is very useful because instead of navigating through different sections, we can understand the system status in just one glance. This dashboard works like a control panel where we monitor performance continuously. Now let's move to the thread management. This is one of the most important part of the system because this is where threads are created and configured. On this page, the user entered a thread name and select a, like here it can enter a name and can select the priority level such as low, medium, and high. And here they can select the thread type, the CPU bound, and input output bound. And here they can set their durations, like from here they can increase and here from they can decrease. For example, I'm doing here 7 and I'm doing medium. I'm selecting this and I'm selecting my thread type CPU bound. Okay, and let's see, I'm creating one thread and it will show me running in this queue order. Whenever it will complete, it will show me completed here in this. Here we can create multiple threads with different priorities and durations to stimulate real world scheduling scenarios, and this helps us to test how the system behaves under the different conditions. This page also represents the input stage of the system where we define all these workloads. Next, let's move to the scheduler. Now comes the most important section. This is where the actual execution of thread takes place. On this page, we control like start, pause, and this reset. Whenever we click the start button, the scheduler begins the executing threads one by one. We can clearly observe which thread is currently running and how many threads are waiting and how many have completed their execution. There is also visual execution timeline, which shows how threads move from waiting queue to running state and then to the completed state also. This visualization makes it very easy to understand how scheduling works internally, depending on the selected schedule algorithm and the behavior changes. In FIFO scheduling, threads are executed in the same order in which they were added. In priority scheduling, threads with a higher priority are executed before others. This page converts complex scheduling logic into a simple visual process. Now next, let's move to the analytics. This page focuses on the performance evaluation of the system because only visual execution is not enough. We also need measurable data to understand system efficiency, right? Here we can see the metrics such as total execution time, throughput, and average wait pressure. It will show me average waiting time here, and it will show me my thread states, which is running, which is paused, which is spanning, which is completed, and which is failed. And it will show me my distribution also, whatever I selected, medium, low, or high. So there are charts also, these they will show me this priority distribution, and this helps us to understand how threads are behaving and how efficiently the scheduler is working. And this page transforms the system activity into a meaningful insights. So let's move to the next, AI suggestions. So this is a, you can say, smart feature of the system that acts like an intelligent assistant. So it observes the current state of the system, including number of waiting threads, completed threads, and the current scheduling strategy based on this data. So it provides useful recommendations also. For example, if too many threads are waiting, it may suggest switching to priority scheduling. If the system is stable, it may suggest using FIFO scheduling. So it can also detect bottlenecks and suggest improvements to optimize their performance. And additionally, it provides quick action buttons so that the user can directly apply the suggested changes. So this reduces manual decision making and improves system efficiency. So next, let's move to the settings. So here the user can switch the FIFO and priority scheduling and adjust the simulation speed and reset the one simulation or reset the entire system. So this allows the user to modify the system behavior without changing any code. This page acts as a configuration panel. So that's it. Thank you.